few things you should know. This weekend, there are two good events from Hack Miami and Pacific Hackers, which are both excellent users groups run by Rod Soto. Same guy runs both of them. And so this one's SOC 2 audit preparation, and this one is Kubernetes security. So they're both free and online. I highly recommend going to those, and they're worth extra credit. Those are both great groups. And in other news, Parallels now has a virtualization client for the M1 Mac that runs on ARM. So I wonder, I guess it means you can Windows 10 on ARM Insider Preview. So I wonder if you can run an Intel-based VM on ARM-based hardware. That's what I'm not quite sure about here. And that's really important for me because I'd like to get an M1, but if I can't run any Intel-based operating systems, then it would be less valuable to me. But anyway, well, you can't run 64-bit. You can run 32-bit x86 apps. Anyway, it's good progress. If they get a virtualization client running, that will make these Macs a lot more valuable to me. And I heard this podcast, and it's excellent. Nicole Perlroth is a New York Times cybersecurity reporter, and she actually came and talked to our class at City College, San Francisco a few years ago. And she is now writing books. She wrote a book about cyber war, and she's given a lot of podcasts about it. And this one was more clear than the other ones I've heard. They're very good, talking about the consequences of Russian hacking everything and the SolarWinds breach and so on. Really quite scary, and I think quite justifiably so. A very good perspective on this stuff. Coinbase is now selling, and this morning it was valued at $99 billion. Now it's $85 billion. Those are pretty big numbers. So cryptocurrency is huge, despite the fact that it makes no sense at all. So the naysayers like me are certainly being outvoted by a whole lot of money of people that think this stuff is great and it's really going to be in for the long haul and it's really going to matter. So we will see. If enough people believe in it, it develops some value, and people like me don't matter. We'll see what comes of it all. So I said today, Tucker Carlson irritated everybody by saying, why is it that Fauci says you still need to wear a mask after the vaccine? Why can't we just open everything up? Maybe they're lying to you and the vaccine doesn't work. And, I think that's him just making it too extreme. But I tend to agree, at least, that we should just forget about it. I take the vaccine and then go back to normal. This thing was only 10 times deadlier than the flu anyway. So if they take it down by a factor of 10, then we should just go back to normal. And one of my friends are saying, oh, no, you have to wait because we don't really know if you can spread it if you had the vaccine. And I say, we do know. This came out a while ago. If you're vaccinated, you don't catch it, you don't get sick, and you don't spread it. Other people are trying to say we have to wait for more data, but I don't know why. As far as I can tell, the data is already plenty fine. If you got the vaccine, you can just resume normal life. I do wear a mask when I go out just to conform with the rules, but I don't think it makes any sense. And I told Hector the college, and I said I will be happy to teach face-to-face next semester, which apparently a lot of teachers have not yet agreed to do. But I said I'm happy to do it. I don't think there's any problem as long as people are vaccinated. And of course, when I teach classes, I also put them online so students can connect remotely if they want to. And in practice, most people prefer to do that. So there's not going to be a crowd of students in the room. I always get maybe 4 or 5 diehards that actually come physically, and the rest go online. Anyway, NFTs. NFTs, I think, are even stupider than cryptocurrency. I mean, you're buying something that you don't even own anything. Like you buy a piece of art, you don't even own the piece of art. You just have a sort of symbolic representation that you're the first one that officially got a copy of the art. It's very strange. It makes less sense than a pet rock. But, anything people will trade. I mean, what's the real value of a gold or diamond either? I mean, why should I feel like a chunk of gold is worth a whole pile of money? It's just a tradition. It's just a social thing, right? All money. Why do I feel like this piece of paper with George Washington on it is worth something? There's no intrinsic value there either. So if enough people believe it, it becomes true that this stuff is worth something. It's only yeah, that's right. That's the thing. And that's the argument of the cryptocurrency people. They say, well, this makes as much sense as any other fiat currency. And they have a point, I guess. The difference to me, though, is that fiat currencies are backed by the government. They have the U.S. military, the U.S. banking system, the U.S. legal system holding up the dollar. And there's nothing like that holding up a cryptocurrency. So that makes me nervous because I've been part of the financial structure. I think it's there for a reason. But yeah, certainly at the moment, people are throwing a ton of money into cryptocurrency. So a lot of people believe in it. Anyway, that's the thing. Right now, there's a pile of money to be made there. I don't think it'll last, but maybe I'm wrong. Anyway, this one's pretty big news. So there was the Stuxnet attack a few years ago when the United States and Israel worked together to sabotage the uranium isotope separators in Iran. And Israel just did it again. They did it in a really scary way. They, of course, they haven't officially admitted that they did it, but they've come very close to admitting it. And the United States hasn't admitted that we were involved. In fact, they have said we did not know about it, but nobody knows if that's really true. But they certainly, our official statement I heard yesterday, they don't seem bothered by this at all. They don't feel like Israel betrayed us or anything, which has surprised me because this is probably going to undercut our ability to get Iran back into the nuclear deal, which is what Biden wanted. But anyway, what Israel did, apparently, somebody did, is they got an insider to plant bombs in the power station that powers these nuclear devices, these nuclear isotope separators. And it went off. It was not a cyber attack. It was some kind of insider attack. They bribed somebody or they managed to sneak bombs into some of the construction material. So that's very concerning inside Iran. They appear to have traitors inside their company. At least that's what they feel like. Yes, a lot different than Stuxnet. Anyway, so they blew up a bomb. It took down the power stations. And I thought, that's pretty stupid because they'll just put in more power and bring them up again. But apparently, when you cut the power for these high-speed centrifuges, it tends to destroy them. They said they physically broke the centrifuges again. And that's what Stuxnet did. Stuxnet just made the power fluctuate to these centrifuges, and apparently they can't withstand that. Yes, this is Mossad. I think it's the Israeli spies in both cases. And in Stuxnet, certainly with American cooperation. And this time, it is not clear whether there was American cooperation yet. I would tend to think not, though, because this does seem to contradict the current American policy, which is to try to get Iran back in the nuclear deal. But anyway, Israel has been very public and very clear that they will not allow Iran to have nuclear weapons because Iran has constantly said Israel has no right to exist and we're going to wipe it off the map. So the Israelis understandably feel like they will be the first target of those nuclear weapons, and they really don't want Iran having any. So they've been just killing their scientists and blowing up their stuff. They're not messing around. There's sort of a low-level war going on there. Israel is willing to do any rotten thing necessary to stop these nuclear isotope separators, whether anybody likes it or not. And of course, as an American, my one concern I have is, are they going to start a war and are they going to suck America into the war? That could very easily happen. If a war came out, then America would probably have to join Israel. So there could be another Mideast war we get sucked into over this. That's why Biden would like to get back into a negotiated peace with Iran. But I know Netanyahu preferred Trump. He preferred Trump's position. He wanted a hardline military anger at Iran, not cooperating with them, not making a deal with them. Anyway, so this one I thought was pretty funny. So here's the New York digital vaccine passport. And this guy said he managed to copy somebody else's in 11 minutes flat. He said all he had to do was find a picture of their vaccine card, which they'd put on a social network, and he was able to guess enough information to log in as them and then have a valid pass. So apparently, whatever you do to connect it to the online record of your vaccination, it's pretty easy to guess or cheat your way in, he says. So that would be interesting. Yep, I see the comments are right on track. Another Mideast war. I don't know. We've had a bunch of wars out there, and Lord knows Biden would like to get out of the wars out there, but events might suck him back in. Anyway, the MyPillow guy, this guy that was like a big celebrity in the Trump gang and on Fox News and stuff, but managed to get in so much trouble by saying so many outrageous things that he got banned from like Trump Fox News and Newsmax and all those things because he's getting sued for billions of dollars from people who make voting machines because he keeps lying about them. So now he's making his own social network where he can say any rotten thing he wants. And so this might already be out. If not, it'll be out pretty soon. We can join it and see how it works. Lord knows what's going to happen. He's claiming that he's going to censor it to remove like swearing and stuff, but he won't censor you for saying conspiracy theories and stuff. Obviously, that's the whole point of it. So we'll see what comes of it. I would expect when it comes up, it will probably be full of ridiculous cybersecurity vulnerabilities. A lot of like non-technical people say, oh, we'll just hire somebody and put up a Facebook clone, and you'll find out that there's a lot more to it than you think. Anyway, so all right. Let me close these and get to the official stuff. So here we are. This is 128. And we're down to the last Android lecture, which is pretty much a review of everything we've done so far, writing secure Android applications. Then we're going to talk about iOS. And there are some hands-on iOS projects, but they're pretty hard to do. You really need an iPhone. You really need a Mac. So they're all extra credit. And a few students got iPhones from me. I have some more iPhones I can loan or sell people if they want them. If you want to try these iPhone projects, I found them they're quite difficult. And even more than the Android projects, if you want to believe that, they seem to go out of date. So I say that some of the phones couldn't be jailbroken, but I have 2 jailbreaks here now, and I'm going to be working on it. I'll be trying to demonstrate some of these iPhone projects in the remaining few weeks of the semester. But if you don't want to do them, that's why they're all extra credit. You can just do the Android projects if you don't want to mess with an iPhone. For example, if you don't have a Mac, then just forget it. You really can't get much of anything done without a Mac. Anyway, so there's not much left of the semester. I just put out the midterm grades last night, and so now there's just a few weeks left and then final. So the chart for calculating your final grades is in Canvas. Some people already have enough to have an A for the whole course, which is fine. You just need the total number of points. You don't necessarily have to take the final. And there's still plenty of time to catch up if you want to. Anyway, let's talk about writing secure Android apps. We've been talking about attacking Android apps all this time, and this is the other side of it, just another way to look at the same information, how to make your app secure. Yeah, when you could jailbreak, yeah, I remember you could, that's right, that's what I did with a friend of mine years ago. She wanted to jailbreak her iPhone, and all you had to do then was go to jailbreakme.com and go swipe, and that jailbroke. And of course, Apple doesn't like it, so they keep patching stuff, and the jailbreaks keep getting harder. That's really, in a way, it's an improvement in cybersecurity. All right. So anyway, there's the common vulnerabilities you'll find. We've talked about there's code injection, where you can type in data and include code that gets run, logic flaws, insecure storage, and logging and communication. And so here's some general principles apply all over cybersecurity. Least exposure, you just do not expose any more of your app to outside inputs than you have to. That's what the attack surface thing does in Browser. If you just don't accept input from any more channels than necessary, then you have what's called a smaller attack surface, which would seem to be a more secure thing to do. But we'll talk about security mechanisms and obfuscation mechanisms that don't really strongly prevent an attacker from getting in your app, but they just irritate the analyst and therefore slow them down breaking in, make more likely to give up and go attack someone else. So least exposure, you're minimizing your attack surface. So you don't let your app connect to, say, SMS messages if it doesn't need to. You don't export activities that shouldn't be exported, and so on, so that any kind of signals coming into your app should be minimized. So we talked about the attack surface, how many activities, broadcast receivers, content providers, and services are exported. And, the most secure app would have nothing exported except one activity, which is the main one, to open up the main splash page. That would be the smallest attack surface you could get. In that, at least regarding those input types. So don't store data that you don't need to store, like passwords. If you store it in the private directory of the app, then it's not directly available to other apps. They need a root exploit to get over, but that's not that hard. The SD card is even less protected. And so, if you really need to store a secret on there, you should be using the Android keychain. Or better, just figuring out how not to store a secret on the phone. So you got inputs from all these network transmissions like Wi-Fi and Bluetooth and such. And so if you're going to get an input from somewhere, it would be nice to verify that it really came from a trusted source with some kind of, digital signature or something. That would be best. If you're going to add code to your app while it's running, by running an executable or loading a class of data from somewhere, then you really ought to be verifying that you are really getting the code you were supposed to get from the real trusted source with some kind of cryptographic signature or something. That would be a lot better than just having a part of your app that loads code from some HTTP source that might be modified. So don't turn on any permissions you don't need, especially risky permissions like install packages, because users usually don't understand these and they'll just agree to anything. But your app is taking on a responsibility if you give it all these high powerful permissions. So you can also include as many files as you want in the APK, and just like GitHub repositories, it's fairly common that people forget and put extra files in the APK that shouldn't be there that might contain confidential information. So here's the security mechanisms. You trace these functions. In your activities, onCreate is run immediately when you first launch the app. OnReceive is run as soon as it gets anything in the broadcast receiver. The content provider has a series of these, and the service is here that starts. And so those are functions where you should consider if there's a weakness in there where some unexpected input can come in. Click on anything that gets me into the app. Yeah, that's right. That's what's happening. So all these exported components should be limited with permissions. Instead of exporting them with no permissions where anybody can use them, you should export them with some kind of permission, like signature, so that only other apps from the same company can get to them, for example, that sort of thing. If you really want to offer some component for public use by everybody, then you have to be much more careful to consider all the possible malicious inputs. So, if you secure your app, there is a task manager. You click on a little square in the corner and you see a little page of every app that you can flip through, and that page is a snapshot of the screen of the app. So that might contain something like a password or confidential information. So if you don't want that to happen, you can use some of these things to show a blank screen instead of the details, or to remove it entirely from that list. If you want to prevent tapjacking, remember tapjacking is where you put up an image and people click on the image, but unbeknownst to them, they're actually clicking on whatever's behind that image because you have layers of images. And so here's a way to prevent that, where touches will not be passed through this component to the component below them. So that's a good thing. If you want to turn off the dictionary, then if the dictionary is not turned off, then when you type in things like your password, it will be remembering that, and then it will suggest it as an autocomplete later on. So if you're going to have an input, then you can put this attribute there, and then it will not consider what's put in that input to be the kind of text it should remember and suggest again later. Fragments are these URL elements. You have a URL and then a pound sign and then some more data, and it turned out to be pretty dangerous. You could inject stuff through fragments, so they've been blocked by default. You can allow them if you want to, and then have a whitelist of allowed fragments, but allowing arbitrary fragments is not considered wise anymore. And so make sure that if you have activities in your app like various pages, we've talked about this for things like that insecure password manager. If there's an authenticated activity, you should not be able to go directly there from the app not starting yet. You'd have to pass through the login step. So you should make sure that your authenticated activities are authenticated. So you should have some kind of app-wide authentication variable, sort of like a cookie, where it knows when a request comes in whether it is coming from a logged-in user that has authentication or not. This will mask password displays so they don't draw on the screen, so people can't look over your shoulder to read them. And you can choose whether to make something browsable. It's risky. If it's browsable, then any intent with a method, a schema at the front matching it, can launch it. And so it's a very broad way to export things, and quite risky, and you probably don't want to do that for most apps. Then there's content providers, which are the little SQLite databases. They used to all be exported, but not in modern versions of Android. So if you are going to allow your app to run on really old phones, which you might very well want to do just to broaden your market, then you'd have to put in this stuff to put exported equals false for your content providers, so that if they do run it on old phones, the content provider isn't just automatically exported. And in order to prevent SQL injection, which is true of every device, what you do is you use prepared statements. Some people also call them parameterized queries. They're very close to being the same thing. And the point is you have a query, but instead of just having type equals data from user, you have type equals question mark, and then you have user input here. So the user input is separately handled in the statement and is not just placed between quotes, which can then be mismatched with quotes that come in the input. It's a separate field which cannot be confused with the other parts, so there's no way to inject code into the user input. All right. Directory traversal is where you have a file name and you put in .. to browse to some unexpected directory. So you can remove the .. If you use get canonical path, then it will take the path to the object you're referring to and give you the full path from the / right down to the end. And so here, for example, you get the canonical path, and then you make sure it starts with the expected base folder. So I'm only supposed to be referring to things in a certain folder, and I get the data from the user, and then I make sure that it's still pointing to that folder. This is a good way to do it. If you use pattern matching, subpath, this would apply to subpath, but not the subdirectories. So you can do it with path prefix, and then it would anything that starts with subpath and then goes on, or you can do path pattern, which will let you use wildcards. So these are pattern matching as ways to make sure that whatever your security property is, it applies to the variations of a path. This is another thing we saw in that insecure password manager. There was a control that applied to just one path, and if you did something like add an extra slash at the end, it no longer matched that path. All right, so here's broadcast receivers. And remember, there are these secret codes, things you can dial in the numerical dial pad, special numbers that do things, and they are not really secret. You can download an app on the App Store that will show you all the secret codes, so don't trust them to remain secret. All right, so when you're going to store files on the phone, you can set permissions to make them private. And but that of course won't stop you from getting in with a root exploit. Encryption is better. If you're going to use symmetric encryption, you use AES, although I don't know where you're supposed to put the key. RSA is much better, asymmetric encryption, where you have a key that is not on the phone, it's on a server. The book talks about hashing, but they're not very sophisticated. For real hashing, you not only have to use a secure hash function like SHA-512, you have to use salting, where you add some random characters to what you're hashing, and then stretching, where you repeat the hash thousands of times if you want to make something safe. It's better to just use standard libraries like the Android keychain. A random is a function. A lot of random number generators are not very good. For example, here's one where you can initialize it with a random generator, which is good. If you don't, here's a random function that just uses random and makes a new random of 1. 1 is the seed, and it's always the same. So if you do that, you can run it online, and you'll see every time you run it, you get the same numbers. This is quite a common issue. There are lots of cheap random numbers generators in every language, including Java, that really aren't very random, and then there are other ones you use that are much stronger. So a lot of people make mistakes with random numbers like that. If you want to generate a key for something like AES, you can start from a password and then run it through PBKDF2, password-based key derivation, and that just does the same thing as how you make a password hash. It just runs it through SHA-512 or something like that a few thousand times. Yeah, true random number generator is very hard to make. It's a whole lot harder than anybody might imagine. I saw Dan Kaminsky's talk a few years ago at DEF CON about this. There was a researcher in Canada about 10 years ago that got all the public keys of all the HTTPS servers on the internet, just ran a script, and there's about 1 million of them, and found that 1 in 1,000 of them all used the same random numbers, which is really shocking. Thousands of them were using identical keys based on the same random numbers, and he wondered what caused that. And there was a theory that various theories came out, and it ultimately turned out that it was because of this. The random number generators weren't very random. You would buy like a bunch of VPN devices. You boot them up, the operating system starts, then it creates a random number to generate the key, and of course there's 1,000 other devices, exactly the same hardware. You turn them on, it takes exactly the same number of microseconds to boot up. A bunch of them end up with the same random number, and then the same in the key. Making a truly random number is in fact quite difficult. So difficult that in the Intel chip about 5 years ago, they included a hardware random number generator in the Intel chip. Now, a hardware random number generator uses physics. There's a resistor in there, and you run a current through it, and you measure the voltage, and you measure it with precision, so you get the random oscillations in the voltage due to the random thermal motion of the atoms. And that's really very random. So they finally put that in for that reason. And you can buy like extension cards for your computer that are just random number generators that just use a real physical process to be really random. Because, of course, nothing about a digital computer is ever really random. Anyway, so this is one way to do it. You can use a password and run it through PBKDF2 to create a key from it. It's not random, it's related to the key, but it's a way to get a key that's not easy to predict from the password. All right, so if you want to let another app see a file, then you have to give them read-write permissions. And then they can only action at that folder. So here you got the path prefix. So this permission is going to apply to anything that starts with this path. And then if they have this read-write permission, this permission is required to go in there. So they'll have that's how you do it. That's how you let certain other apps in that have that permission. All right, and we talked a lot about secure communication. If people use HTTP, the stuff is sent with no encryption, and that's very dangerous. HTTPS is much better, but a lot of people do not correctly implement HTTPS, like they don't actually verify the certificate chain back to the trusted root, so they'll fall for a forged certificate. And sometimes there are attacks. There are attackers who actually can control a valid certificate authority or clone one because they have stolen the root key from a valid certificate authority, or they are a nation-state attacker that can pressure their certificate authorities into going along with their attack, like China. And so if you're worried about that kind of attack, then you need to use certificate pinning, where you say, not only do I follow the chain back and see that my certificate came from a trusted root source, I also verify that the certificate is exactly this one. Like, for example, not only does it come from a trusted root source, but it must come from DigiCert, nothing else. I know what that source should be. And then you'd know if the government of China tries to man in the middle of your contact, you won't fall for it because they might control a trusted CA, but they do not control DigiCert, that sort of thing. All right, if you want to move data from one app to another, the Android API gives you ways to do it, like activities with intent filters, like we just talked about. And there's the new recent Android versions have more things called chooser targets and shortcuts and direct share targets, more ways to share data with other apps. These are in the API. There are some old-fashioned techniques people use sometimes, like listening on the loopback address on a network port or using the clipboard, and those are much less secure, of course. Those are not very well controlled. They don't have the permissions that these API functions have to limit how the data goes back and forth. And WebViews is the browser inside an app that you can use to open web pages inside your app, and that is often quite dangerous. So if you're going to use it, then you should limit the security risk of WebViews. And there's a series of recommendations here. Don't load any part of it over HTTP, for example, and turn off JavaScript and so on. All right. The manifest is the main configuration file that sets the permissions and other general properties of your app. It turns on whether you can allow backups. You have to be aware you probably want to allow backups if you want to let the user make backups, but then, of course, an attacker might be able to use the backup to get a copy of it. And debuggable is something that you should probably almost never. I can't think of any case where you actually let an app go to production and have debuggable turned on. That's one thing missing from the project, is using debuggable to debug an app to hack into it, but that's certainly a weakness. I'd like to add that to the projects. Haven't done that yet. I think that Insecure Bank is in fact debuggable. It'd be a good thing to add to that project. I might get around to it, but I think I'm going to switch to iOS pretty soon. Anyway, you choose your SDK version. it is more secure to only allow your app to run on more modern versions of Android, and that would be a higher SDK version, but then of course you're losing some of your customers that might have an old phone, so this is a business decision. There's a similar one in the world of web apps. Some people make web apps that will let you run really old browsers like Windows 95 because they're trying to target countries where people are still using that stuff, but it's very insecure to do that because Internet Explorer in Windows 95 could only do something like 40-bit encryption. So this is a general problem in all of technology. How do you really want to reach the customers that are using really old, insecure stuff? Because if you do, you're accepting a really low level of security, but if you don't, then those customers can't use your stuff. Android 9, I think we're now up to 11, but I looked up Android 9 when I made these slides, just see some of the new things. DNS over TLS, encrypted DNS lookups, which are becoming standard pretty fast. Supposedly the network traffic is all TLS by default to try to discourage people from using unencrypted traffic. The WebViews are separated. You can't steal cookies from other processes, the usual improvements. Cloudflare gives you a VPN sort of client, something you can use private DNS. This is encrypted DNS, an option you can add on Android Pie. Right, you should turn off logging in release apps. They just shouldn't log anything. I don't see very many apps that actually do this. But only a few apps are dumb enough to put something secret in a log, although I do find it in maybe 5% of apps. And so you ought to have some central logging code which you can easily turn off. ProGuard can do that for you. ProGuard is the free Android obfuscation tool that comes with Android Studio. So people that leave logging on in their app are not even trying. They're not even using the free default tools to secure their stuff, which is true of a lot of apps. Native code is code that is compiled not through Java, but compiled like C++ or C# or something down to real object code, x86 or ARM code, and that's going to have all the binary flaws we're talking about in 127, like buffer overflows and all that jazz. So if you're going to do that, then you got to turn on all these mitigations, which I just wrote a project about in 127. Relocation read-only, stack canaries, non-executable memory regions, position-independent executable code so it can be relocated in memory, and these other mitigations. Those are all the binary mitigations. I use code for the central logging to sanitize inputs. Yeah, that's a good idea. The Dark Rogue's got a good plan. Yeah, good. Anyway, and so here they are. These RPath lets you load modified binaries, modified libraries, so I think this must prevent that from happening. Not quite sure about that RPath one, but these are fairly standard binary protections. Anyway, and so here's some more of these security mechanisms. Here's one that was in one of the projects. In older versions of Android, you could make a custom app that would have a low permission defined, and when you installed an app later with the same permission, it would inherit the old permission setting. So you're able to do that to make Twitter less secure by installing a custom Drozer agent that defines the permission Twitter is going to use later as unprotected. Modern versions of Android, I think they don't let this happen anymore, but your app can also check to make sure that the protection levels are what they should be. So if there's a permission you define and you want it to be signature, then make sure that it is in fact signature and it's not something else like no permission at all available to everybody. If you have non-exported components, then nobody should be able to use them from another app, but root can use them, and so you could add another layer of defense there by having something required like a request token, so that even the root user can't get in unless they know that token. That's one way to make it more secure. And then there's stuff that doesn't really stop an attacker but just slows them down, like obfuscation. If you run this thing through, I think this is -O. There's a trial version of -O, and you see it takes these strings that might be credit card number and password, and all the strings just turn into long, meaningless characters. So that's good. That makes it really hard to find the goodies when scanning the app. You can still get in. I've done it in apps like this where what you do is you write Python to just log every single variable everywhere in the whole app. and then you run it, and it runs dog slow, but it does run. Then you type in the username and password and look for it in the log. You can eventually find out which one of these horrible things is the password, but it does slow you down. It's a lot more work than just having something named password there. And root detection, we talked quite a bit about this in the projects. You search for clues that your phone has been rooted, and then you don't let your app run on rooted phones. This is getting fairly common as a protection measure. Not a bad idea. You can detect emulators like Genymotion. There are various ways to do it. You look for properties. Just like virtual machines, there are clues inside emulators that make it pretty obvious that you're running in an emulator, and malware typically will not run in an emulator. The malware writers for Android malware have learned this. You really need a real physical hardware phone to study Android malware. And you can detect whether it's been debugged, whether debuggable is on, so you can make a check to make sure that your app is not running on a phone that allows debugging. So then you'd know that, I think this is Android debugging, USB debugging turned on. You can refuse to run because USB debugging is turned on, and that's also a very good idea. And you can check to make sure that your app has not been tampered with. Like, that's what I was complaining about. All those projects we did with the Bank of America and others where we take a commercial app and we modify it and run it, the app should not put up with that. It should detect that it's been tampered. It can check to make sure that the signature is really the correct signature from the company, for example, or it can just check a hash value to make sure it's not changed. There are things you can do. Now, of course, you can modify it to take out the verification code, which we did in that MAdHar app, so nothing is ever perfect, but this is good. And besides, when it touches your server, quite a few apps have begun to start doing this. The NFL app did it first, maybe 8 years ago. When it connects to the server, it immediately checks something like the signature, and it says, wait, that's not my real app, so it won't do anything. It won't let you log in and password or anything. It just pops up a box saying, your app is out of date. You must update your app before you can use it. That's a good idea. That's what they really should all be doing. But a great many of them don't. So, anyway, let's take a look at the cahoots. 128, Chapter 9. Good to obfuscate the error. Well, I don't know about the error, but obfuscating your code helps. But yeah, most people just put like an error code number or something, so people might not know what that means. Too detailed of an error helps the bad players. Yes, that's right. Yeah. Error messages are another weakness. Detailed error messages. Oh, a bunch of people came in. All right. All right. I think we got everybody now. All right, so what stops tapjacking? All right, yep, that's it. Touches when obscured. All right, what creates a key from a password? Okay, that's password-based key derivation. Good. All right, how do you stop SQL injection? Yep, prepared statements. All right, and what makes HTTPS more secure? Yep, certificate pinning. All right. All right.